Alright, so in this lab we will need 3 different setups. On the left I have a heating under reflux apparatus. To the right I have vacuum filtration, which we will use twice in this experiment, and in the middle is just a hot plate with a beaker warming up some water. The heating under reflux apparatus involves a West condenser condensing column attached to a round bottom flask that's on top of the heating mantle. Then we have our water going in and up the condenser, and our water coming back out and into the drain. Our first step is to measure out about 1.5 grams of methyl salicylate. Very carefully put the round bottom flask on a cork holder. You're going to open the top of the analytic scale and very slowly add drop by drop into the round bottom flask until it gets to 1.5 grams. You also want to remember to put in a boiling chip. Boiling chip will basically help the boiling process. You don't want the bubbles to get too big and move the vessel or pop the vessel, so the boiling chip allows a surface for the bubbles to form around. We're going to wait here till this mass settles out. So it looks like we'll be collecting about 1.5600 grams of our methyl salicylate. Then we'll be pouring in 15 milliliters of 6 molar sodium hydroxide. And it's a good idea to use a funnel for a couple of reasons. One, you can avoid spillage, and 2, you want to avoid contact to the opening of the glassware, especially when heating under reflux. The glassware can stick at the taper joints, so you want to make sure to avoid contact there. We'll set it up here with our heating mantle. And we're going to turn on our water, and very slowly as well. You don't want the water to rush all at once. The tubes will pop, make some mess, very annoying to clean up. Our water will come in from the bottom, go out the top, just as before. And we're going to turn it on. About 60 to 70 should be fine. We'll start warming up our mixture, and you want to leave it for 30 minutes. It's important to note that you don't want to use a cat clamp here. That's because since there's heat, it's very close to the heat source, it has a high chance of melting, and it's made of plastic, so it'll sit there just fine. So it's been about 30 minutes now. This reaction mixture has been heating up in the round bottom flask on the bottom. The vapors will go up into the West condenser and cool down with the water. The vapors will condense. As you can see, there's liquid flowing out the bottom of the condenser. If we zoom in here, you can see a reflux ring. The reflux ring is basically the boundary where the vapor starts to condense. And you want that reflux ring about the midway up the condenser. You don't want it too high because then you risk vapors escaping. If you notice here, you also want the top of the condenser to be open. This is to avoid explosion or buildup of gas. You want the gas to be leaving. However, you don't want too much vapor, as I said, to escape, so you don't want the reflux ring too high. And we'll be turning off the mantle now and leaving for another 10 minutes to collect as much of the liquid as possible. Then in our next portion of the experiment, we are going to be using an ice bath that I have prepared beforehand. You also want another small beaker, and then your reaction mixture inside the round bottom flask. You're going to pour very slowly the reaction mixture into the small beaker, and this is where we will be conducting the next reaction. If you notice, there's still a little bit of vapor left. And here we have our 16 milliliters of sulfuric acid. You want to pour it in very slowly. It causes a lot of vapor. Again, you want to avoid spillage, and you also want to mix it thoroughly so that the reaction is complete. Little bits at a time. If you notice, there's going to be a white precipitate that starts forming. You want to keep mixing. Perfect, and then just a little bit more. Note that you may need a little bit of extra sulfuric acid to assure that the reaction goes to completion. Make sure to keep stirring. To check whether the reaction has gone to completion, we will be using pH paper. Now we want a pH of 2 or less. This is how we will know that there's extra sulfuric acid. And when testing the pH, you will not want to put the pH paper inside. Instead, you want to spot it with the glass stirring rod. This avoids loss of material from contact with the pH paper. And we're going to use this pH paper to match on the color grid and check. It looks like we have about 2. Looks more pink than orange, so okay, and just one more step. We're going to leave it in our ice bath for about 5 more minutes. This is just to make sure once more that the reaction has indeed gone to completion. We want the highest yield possible. This white precipitate will be that salicylic acid, so we want to collect as much of that as possible. Here I have my vacuum filtration. It is good habit to use a little bit of the solvent, which in this case is just our water. I'm using our ice cold water. You want to pour a little bit into the vacuum funnel just so that it can seal the paper up and you don't want to lose any material underneath the paper. We're going to pour in our salicylic acid mixture and we're going to filter it out. If you notice, there's very little liquid, a lot of precipitate, so we are going to be washing this a few times. Again, you can just use the solvent to wash it. In this case, it's water, so I'm going to use that same water from the ice beaker and wash it 2-3 times just to make sure that we get all of the solid out of it. Here we have completed the vacuum filtration. I'm going to take the funnel out of the flask and I'm going to remove the solid with a scupula. I'm going to put it into another beaker. If you have noticed that there is a lot of transfer of solid in this experiment, it may affect your yield as it is very easy for solid to remain behind in beakers, flasks, and the funnel. However, I'm going to try to get as much of it out as possible, and the little filter paper you can toss. That one is not important. So here we have our crude salicylic acid. We will be recrystallizing it by dissolving it in boiling water and then allowing the solution to cool down for recrystallization. This gets rid of any impurities. We're going to pour about 20 milliliters of the boiling water. You want to start with a little bit less than usual just to make sure that you don't use any excess. We don't want any excess water because we don't want the salicylic acid to stay dissolved when it cools down. As you can see here, it's very little water, but we want to stir it around just to get it to start dissolving. You want to keep it on the hot plate so that the water continues to boil as well. And then if you notice from this angle, I'm not sure if you can see, but we do still have solid remained in the boiling solution. Little flakes here and there. So we will be pouring a little bit more of the hot water into our salicylic acid to help dissolve a little more. Oof, careful. Beakers are hot. You may want to take some extra precautions, maybe like a mitt or some beaker tongs. Okay, with that little bit, it looks like the rest has been dissolved. I'm going to stir it just to make sure. And once you are confident that all of the solid has been dissolved, you will go ahead and cool it back down. An ice bath is appropriate one more time, and it's almost immediate. If you look over here, you can actually already see it start recrystallizing, which is what we want. Looks great. Once again, we will be filtering the solid from the liquid using a clean Buchner funnel and flask. This time we will be taking the mass of the filter paper, the tape, and the watch glass. As it will be holding the salicylic acid to dry, we want to make accurate measurements and get the exact mass of the acid. Okay, so it has been about 10 minutes. We have let the solid recrystallize. It is important to note that not all of the solid has recrystallized. Although salicylic acid is very insoluble in water at cold temperatures, there is still a microscopic bit that remains dissolved, which is, again, loss of material. All right, you want to make sure you're scraping off as much acid as you can into the funnel, and you will be washing the beaker one more time with the solvent, which in this case is the ice cold water. Here we have collected most of the solid, as much as we could, and we are going to put that on our watch glass as carefully as you can with your scupula. Can collect as much of the solid from the funnel as possible. That's done. And you have your purified salicylic acid. There you are. Now the experiment calls for you to dry in an oven. However, we left our salicylic acid to dry over the weekend, so it is completely dry. It is time to take the melting points and compare our experimental salicylic acid to that of a benzene derived. Here we have capillary tubes. You'll need 3. One for our experimental, which is on the left. You'll need another one for the benzene derived acid on your right. And the third capillary tube is for a 1-to-1 ratio mix. And then here we have a drop tube. You basically just put the capillary tube through the top, comes bouncing down the bottom. It better collects the substance at the very bottom of the capillary. There we go. And you put it into your melting device. As I zoom in, you can see the 3 capillary tubes. It's important to record the temperature at which they each start melting, as well as the temperature at which they stop melting. You're going to get a melting point range, and that'll help you better with your analysis. And there you have it, a complete synthesis of salicylic acid.